Hi, Assalamualaikum warahmatullahi wabarakatuh. This is for MMJ 40102 Professional Engineering. We are from group Black Flag and our title is the Mexico City Metro Collapse. For the group members, I am Muhammad bin Ashraf bin Ciani, and we have Muhammad Iqbal Shauki bin Hassan. Also, we have Numan Haris bin Nur Khairi, and then we have Ahmad Akif bin Ahmad Shahrizal, and the last one is Muhammad Ifan bin Abdul Wahab. So, our lecturer name is Dr. Muhammad Shihabuddin Ismail.
Hi, my name is Muhammad Iqbal Shauki. For the table of content, we have Chapter 1, Chapter 2, and Chapter 3. For the Chapter 1, we have Introduction, Cause of the Accident, Ethical Issue, and Code of Conduct. For the Chapter 2, we have Risk Assessment, Hierarchy and Discussion, and Conclusion. For the Chapter 3, we have a conclusion. For Introduction, the May 3rd, 2021 Mexico City Metro tragedy involved the collapse of an eastbound train between Olivos and Tenzonco Station, resulting in 15 dead at the scene, 26 people affected, and 98 hospitalized. This marked the Metro deadliest incident since 1975, raising a concern about safety and infrastructure integrity. It was culmination of ongoing technical issue on Line 12, initiation a partial collapse in 2014 to 2015, further accentuated by a earthquake in 2017. Line 12 evolution from an underground to the overground system with steel wheel train contribute to track instability. Carso, responsible for the collapse section, denied wrongdoing, but Carlos Slim agreed to repair it for free. Legal action again. 10 former officials, including the project director for manslaughter and property damage, is pending trial, highlighting the severity and quest for justice after this preventable tragedy. Next part is 1.2 Cause of the accident. Empresas ICA, along with Alstom, Mexicana, and Grupo Carso, undertook the Mexico City project, yet critical flaws emerged despite their collaboration. Mayor Claudia Sheinbaum enlisted that Nox Veritas DNV, a Norwegian risk management firm, to investigate the collapse. DNV on June 16, 2021, report highlight 6 structure deficiency: poor welding of Nelson stud, porosity in stud beam joint, missing stud in critical beam, varied concrete uses in the gilder, incomplete weld, and supervision control lapse. This issue collectively weakened the overpass, emphasizing the need for stringent construction practice to ensure the infrastructure safety and integrity. Next part is 1.3 Ethical issue. The collapse of the Mexico City Metro overpass has raised a very ethical concern that demand attention. This encompasses the responsibility of the infrastructure project, especially public transportation, to prioritize safety inherent to construction standard and the credibility of involved entity. The DNV report underscore ethical aspect tied to quality assurance and oversight through construction, corporate responsibility, notably for companies like Carso, require transparent communication and accountability for error. The step to rectify mistake and government oversight also hold a significant necessitating as effective framework and ethical conduct to prevent such accident, communication transparent post-accident, fair legal process, and addressing this ethical consideration are vital for fostering a transportation system grounded in safety, transparency, and social responsibility.
Next, we have 1.4 Code of Conduct. In the aftermath of the devastating collapse of Line 12 of the Mexico City Metro on May 3, 2021, ethical consideration took center stage as the city confronted the urgent need to address public safety, ensure accountability, and enhance transparency. Rooted in a commitment to ethical practices and responsible engineering standards, such a code becomes a cornerstone in rebuilding public trust, fostering a culture of safety, and charting a course toward resilient and sustainable infrastructure development in the future. The ethical principle embedded in this code will extend to transparency in communication, accountability for those involved, a dedication to continuous improvement to prevent similar incidents, ultimately reinforcing a commitment to public safety and the well-being of the communication. First, conduct of registered person. Every registered person shall conduct himself honorably, responsibly, ethically, and lawfully. Professionals involved in the Mexico City Metro collapse must adhere to a stringent code of conduct, emphasizing honorable conduct, responsibility, and ethical behavior. This ethical framework guides immediate responses and investigation, establishing a foundation for long-term practices that prioritize safety, accountability, and public well-being. Upholding these principles is crucial for restoring public trust and fostering a future of responsible engineering practices. Second, responsibility to employer, client, or profession. An registered person shall at all the time hold paramount the safety, health, and interest of public and take responsible steps to reduce the foreseeable adverse effect to professional engineering services on the environment. In the aftermath of the Mexico City Metro collapse, the ethical mandate for a registered person to hold paramount the safety, health, and interest of the public takes of profound significance. Simultaneously, the obligation to take reasonable steps to reduce the foreseeable adverse effect of the professional engineering services on the environment become integral to responsible post-incident practices. Upholding this commitment is essential for rebuilding public trust, demonstrating accountability, and establishing a foundation for ethical engineering practices that prioritize safety, health, and environmental sustainability in the aftermath of the Mexico City metro collapse. And then we jump to 2.1, which is risk assessment. Risk assessment is the process of evaluating the risk to safety and health arising from hazard at work. A risk is defined as a combination of the likelihood that hazardous event will occur within a specific period of time or under specific circumstances, as well as the severity of injury of damage to people, health, property, or environment suffer as a result of the event. Considering the principle outlined regarding risk, hazard, and risk assessment with the Mexico City Metro overpass collapse event, the management team should prioritize the identification and assessment of risks associated with structural project. Specifically, attention should be directly toward potential hazard related to construction activities involving load-bearing structures and scaffolding. As you guys can see, to calculate the risk equal to likelihood, which is capital L, times severity, S. So as you guys can see, likelihood, L, is an occurrence that is most likely to happen in a certain time frame of set of condition. And then severity, S, is the outcome from an event such as severity of injury or health of people or damage to property or insult to environment or any combination of those caused by the event. So this is the table of likelihood times severity. As you guys can see, it have three type of hazard, which is green, yellow, and red. Which is green is low, yellow is medium, and red is high. By selecting the severity column that most closely describe the risk outcome, the description that most closely matches the possibility that the severity will occur can then be found by following the likelihood row. The box containing the row and the risk level is where column meet. The step that must be prioritized in order to properly control workplace hazard can be done using the relative risk value. So this is the level of hazard based on the table above. Hazard marked as a high risk need urgent attention to protect life, safety, and the environment. Clearly identify and assign responsibility to individual for taking immediately action and follow up. Consider using detailed risk assessment method like quantitative risk assessment to figure out the effective ways to control and minimize this risk. As you guys can see, we have index which is 1 to 4, 5 to 12, and 15 to 25, which is 1 to 4 is low, 5 to 12 is medium, and 15 to 25 is high. For the high, you guys can read at this column, a high risk require immediate action to control the hazard as detailed in the hierarchy of control. Action taken must be documented on the risk assessment from including the date for completion. For the medium, a medium risk requires a planned approach to controlling the hazard and applies temporary measure if required. Action taken must be documented on the risk assessment from including the date for completion. And for the low, a risk identified as low may be considered acceptable and further reduction may not be necessary. However, if the risk can be resolved quickly and efficiently, control measures should be implemented and recorded. For this table, this is we call hazard identification and risk analysis. So, as we can see, we have a work activity, hazard, and which can affect, and we have a likelihood, severity, and risk. I give example for the number 1. The work activity is structural design and engineering oversight. The hazard is failure of structural component leading to total collapse, which can affect death. So it's very dangerous. As you guys can see, the risk, we calculate it. For example, likelihood times severity, we got risk, and then likelihood is 4, the severity is 5. 4 times 5, we have a 20. So 20 include in the range of high hazard, so it's very dangerous. And for the second one, we have a welding procedure, welder qualification and inspection. The hazard is improperly execute welding, which can affect electric shock. So for the risk of this hazard is medium, which is 12. And for the number 8, the number 8 is working in hazardous weather condition. The hazard is accident, which can affect lightning struck or fall. But for the risk, it is low because it's just for in the range of low hazard. Thank you.
Hello, my name is Ahmad Akif, and now I will talk about 2.2 HIRACH, which stands for HI for hazard identification, RA for risk assessment, and RC for risk controls. So, the recent years have seen hazard identification, risk assessment, and risk control become integral to planning, management, and business operation, serving as cornerstone of effective risk management. Organizations conducting workplace risk assessment have observed notable positive change in their practices. Those engaged in risk assessment recognize and address substandard acts and working conditions promptly. Legislation mandates a systematic and documented approach to ensure reliability and completeness in the analysis, emphasizing that risk assessment should be an ongoing process rather than a one-time effort. Okay, now as we can see in the mind map, okay, that is the mind map of the key purpose of HIRACH. Okay, the first one, we can see that identification of factor causing harms, which means to pinpoint all factors that may pose harm to employees and others in the workplace. The second one is assessment of likelihood and severity. That means to evaluate the likelihood of harm occurring in specific circumstances and assess the potential severity of the associated risk. The third one is implementation of preventive measures. That means to empower employers in planning, implementing, and monitoring preventive measures, ensuring effective control of risk continuously. Okay, as we can see the table above, the table below, there's 3. It's about the hierarchy process involves the 3 main stages. Okay, the first one is hazard identification. So what is about the hazard identification? It means that the initial stage focus on identifying hazards associated with the work activity. Okay, the second one is risk assessment. That means once hazards are identified, the second step involves estimating the level of risk and comparing it with the acceptable risk tolerance. And last one is risk control. Risk control is the final stage, entails implementing methods or action to control that the identified risk, ensuring the hazards do not pose harm to workers. Okay, now this schematic approach ensures a comprehensive understanding of potential risks, promotes continuous improvement in safety practices, and protect the well-being of employees and others in the workplace. Okay, as we can see, here is the table of hazard identification. So there is about 8 hazard. Okay, we have the risk tolerance and action planning. Okay, now I will explain about this table. Okay, the high risk activities, as we can see, which the tolerance of 20, the first one, which is cause of failure of structural components leading to total collapse. In order to control the risk, implement rigorous quality assurance and control measures during the construction. Conduct regular inspections and maintenance of structural components, and develop contingency plans for evacuation and emergency response in case of structural failure. Okay. Then we can see medium risk activities, which is the risk of tolerance 12 for welding procedures. Welder qualifications and inspection. To address this, consider implement hiring qualified and certified welders with proven experience and conduct regular inspection of welds during and after construction. And the last one is low risk activities, such as working at high place, while the lowest risk of tolerance 3 for accident hazards indicates effective control measures. Continued vigilance is necessary. Enhance awareness and mitigate potential risk by using fall protection system. For example, guardrails, safety harness, and lifelines. So 3.0 conclusion. The Mexico City Metro collapse served as poignant reminder of the vital role ethical consideration play in engineering, public safety, and well-being. The incident, marked by construction and design deficiencies, reveals a complex ethical landscape urging professionals globally, including those in Malaysia, to prioritize safety, engage in transparent investigation, and commit rectifying errors. The broader commitment to minimizing environmental impact acts a global resonance. For Malaysia, the incident underscores the importance of strengthened oversight, adherence to construction standards, and proactive risk management. It calls for embedding transparency, responsibility, and continuous improvement in engineering practice, fostering a culture of ethical conduct, especially considering Malaysia's diverse ecosystem. The incident served as a catalyst for a cultural shift toward an unwavering dedication to safety, environmental sustainability, and public welfare, offering crucial lessons for a resilient and ethically guided future in infrastructure development globally, including Malaysia.